What's going on, guys? Let's do this problem right here. The question is asking to find the work required to lift the chain that is hanging on the roof right here, and this is the length 20 meter. And let's see how we can do this. So first of all, let's look at this one right here. So if we have m mass in the bottom, and if you want to lift this one into h height, to find the work required, we simply take the force required to lift this one is going to be mg, right? Mass against the gravity, so it's going to be mg, and the force required to, the work required to lift this one is going to be mg times this height. So that's how we find the work. Here we have this chain right here. So what we are going to do is we are going to cut this into small parts, and that's going to be the small parts, mass of the small parts dm, and this small height is dx, right? So we are going to find this one in terms of this one and see every part of this, how much work is going to require to lift each part of this dm dx, right? So let's see how we can do this. So first of all, dw is going to be as we discussed here, it's going to be mg times h. But here we are talking about the small part. So for this one, it's going to be dm g times the x, right? So x height, the total height is x, and that's the work required to lift this one. And let's see. So therefore we can integrate this one in terms of dw. If we integrate this one, this will give us the work. So let's do this one. So the limits of integration here is going to be 0 to 20, because we are trying to lift from 0 distance to 20 distance, right? So 0 to 20 is our limits of integration, and dmg x. So if you look at this one, we have dm and x, but we can't really integrate this one since we have two different variables. So we have to try to convert this one into x. So let's see how we can do this. And if you look at this mass per unit length equation, what happened? If you multiply this one by a length, what's going to happen? That will give you the max. So if I multiply c by that distance, here the distance is dx, right? C by dx, that's going to give us the dm, right? So instead of writing dm, we can plug this one c dx. So let's plug this and see what we get. So here we are going to have 0 to 20 c dx and also gx. Now c and everything except x is going to be a constant, so we can move this c and g to the front. So this cg integral 0 to 20 x dx. So let's now this is easy to integrate, so let's do the integration. This is going to be cg times x square over 2, and going from 0 to 20. Now we can apply the values. So this is going to be cg 20 square over 2 minus 0 square over 2. So 0 square over 2 is going to be just 0. So this is the only value we are going to calculate. So this is we already know the c is going to be 2. So half times 2. This is only 20 square. So half times 2 times 9.8 times 400 is equal to what? 9 times. So 9.8 times 400. That's going to give us 3,920 joules. So that is the work it's going to require to move all this chain to the top part. So that's how we calculate these kind of work questions. I hope you guys find this video helpful. See you next time.